So let's look at the solid magnesium hydroxide, MgOH2. The solubility is 1.8 times 10 to the negative 11. That's the KSP, I'm sorry. So what can you say about magnesium hydroxide? It's not going to dissolve very much. That's why it's not a strong base, because you won't get any of the OH minuses. So how would you increase the solubility of magnesium hydroxide? That's right. Why don't you add some acid in the water, and the H plus will yank that OH minus away from the magnesium, dissolving it. So what you've done is you've increased the solubility of magnesium hydroxide by just adding H pluses in the water. So that's how you can change the solubility as well. Here you can see the magnesium hydroxide is in solid form right here. It's a white solid. Upon addition of H pluses right here, do you see how the solid is starting to dissolve? Right? Because what happens is that H plus attacks that OH minus, making water. There's two of them, so you're going to need another H plus. You make two waters. And now your Mg plus 2 is free. You just increase the solubility. See? It's gone. It's not gone, it's just dissolved. You can do the same thing. It says if a substance has a basic anion, an example of basic anion is OH minus. It will be more soluble if you add some H pluses in there. And the opposite is also true. If you have something, an acidic cation, then you can dissolve something with basic solution. An example of an acidic cation would be NH4+. That's acidic, that's a cation because it's positive. And you can increase solubility by adding something basic, like OH minus. Okay, it says, which of the following substances will be more soluble in acidic solution than in basic solution? Well, nickel 2 hydroxide. This will dissolve more in an acidic solution because the H plus will bond with the OH minus, making water and freeing that nickel plus 2 ions in solution. Okay, calcium carbonate. Well, I have two ions here, plus 2 and minus 2. If I add Ca plus 2 in an acidic solution, nothing will happen. They're both positive. If I add the other ion, CO3 minus 2, in an acidic solution, what would happen? Calcium carbonate, by the way, is what seashells are made of. Okay? So if you put acid in there, what you will do is the H plus will take away the CO3 minus, and what it will make is carbonic acid. And that is unstable as it decomposes into CO2 and H2O. So yes, you will dissolve seashells if you put it into an acidic solution. Okay. How about BAF2? It says, will it be more soluble in acidic solution than in basic? Which one of the following will be more soluble in acidic solution than in basic? Okay, so let's see if this will be soluble in acidic. Ba plus 2 plus H plus, nope, nothing will happen. F, 2 F minuses plus HF plus H plus. Will that make HF? Yes, it will, because HF is a weak acid, so F is a strong conjugate base. It'll take the H plus will take the F and dissolve the solution. You're going to have barium plus 2. So this one will be, yes, acidic. So this one will be an acidic solution as well. Okay. Let's see AgCl. Plus and plus. Will Ag plus bond with H plus? Nope. Will Cl minus bond with H plus? Nope. So no, this won't dissolve in an acidic medium. So acidic? No. Will it dissolve in a basic medium? Let's check. Will Ag plus bond with OH minus? I don't know. Let's see if it will do it. Let's look at the solubility chart. So the reference sheet, AgOH, silver hydroxide over here. Okay, it's not on this chart. Oh no, wait, no, it's not on this chart, but I did look it up. 2E negative 8 is just not on this one. So this is AgOH. Oh, the parenthesis is not there. It's plus 1 minus 1. So to go left, it'll happen at 2E negative 8. That's the equilibrium expression. So it's not going to want to form the liquid. So it wants to make the solid. Yes, it wants to make a solid. But did you dissolve it? No, it's still a solid. So no, you did not increase the solubility of this. So that won't work either. Okay, so only A, B, and C will dissolve in an acidic solution. Okay, now let's look at complex ions. Let's look at the word ion. Ion has a charge, plus 1, plus 2, plus 3, whatever. Okay, negative 1, negative 2, negative 3, it's just charged. Complex means two different substances are bonded together. Here's some examples. This is a complex because there's silver ion and ammonium. An ammonia, there are two things, two or more. There's silver and then there's CN. That's a complex. So that these are called complex ions. Okay, let me show you an example of complex ions. This is a complex ion. Here, aluminum has a plus 3 charge and water all around it. There are 6 of them, and it's written like this: aluminum H2O, aluminum complex with 6 waters. And the whole thing has a charge of plus 3 because aluminum has a plus 3 charge and water has 0 charge, so 0 plus 3 is a total of plus 3. Okay, it's a complex ion because it's an ion and 2 or more substances are complex together or bonded together. The reason this happens is because aluminum here is lacking electrons, and water here has a lot of electrons, so it's donating the electrons to the aluminum. Aluminum is acting as a Lewis acid. Okay, so that's a complex ion. Okay, here's another complex ion, copper, plus 2 charge with some ammonia with donating electrons there. So this complex ion is right here. Copper with 4 ammonia. 2 plus, complexed with copper and ammonia. Okay? When you put these together, copper plus 2 and NH3, look at the equilibrium constant. 5 times 10 to the positive 12. That means they really want to be complex together. They really want to be bonded. All of these, look at that, times 10 to the 29. They really want to happen. So what these do, these are, by the way, called ligands. And in this case, they're donating electrons to these cations. Okay, the bond is so strong that what the ligands will do is they will steal these ions away from any solids. So what the complex ions do is they steal the metal, and then because it's still an ion, it is aqueous. It's still dissolved, so you can dissolve it more. Okay, so complex ions can increase the solubility. Here's an example. Let's look at a solid chunk of AgCl. AgCl. Do you see that white powder there? That's AgCl. Let's look at the reference sheet for AgCl, silver chloride. 1.8 times 10 to the negative 10. That means it does not want to dissolve. So what do? We add drops of ammonia, NH3. What happens is that ammonia steals the Ag away from the Cl, bonding with it, making a complex ion, and that K, the F means formation in this case, it's just another equilibrium constant, is 1.7 times 10 to the positive 7. Huge. Okay, once it steals the silver, it has a +1 charge and it's still aqueous. So in essence, you just dissolved Ag plus, and Cl minus, but the Ag plus is in the form of a complex ion, of course, which is fine because it's still dissolved anyway. The whole thing has a charge of +1. Both of these are dissolved in water. And the Kf formation is huge. So what do complex ions do? They increase the solubility. Okay. One more idea that is in the book. I haven't seen this on the AP exam, but it's kind of interesting. This is aluminum. Okay, so aluminum normally has a +3 charge. When you drop it in water, water surrounds it, of course. Okay, so you're going to have 6 water molecules complexed. But if you remove the H plus here, the H plus here, the H plus here, you have OH minuses here. You have 3 OH minuses. And you have 3 water molecules acting as Lewis acids. So you can see 3 waters. The charge of this whole thing, this is 0, this is -1, this is a +3. Oh, there's 3 of them, so a total of -3. So the whole thing is 0. And I wrote them twice. This system right here can actually act as an acid and a base. It's amphoteric. Because if you add OH minus, it can remove this H pluses, and it can remove 3 of them. So right now, this substance, aluminum hydroxide, is acting as an acid. It can also act as a base because all of these can take H pluses. So aluminum hydroxide can also act as a base, and it can also act as an acid. And so it is amphoteric. Okay, so the way you write it, I know the book does it. Let me just erase this so it's easy to see. Okay, if you add OH minus to it, okay, it will, that delete buttons. This OH minus will take one of the H's from here. Okay, so it'll take one of these H's. So now you have aluminum. Now you used to have 3 waters, now you only have 2. And you used to have 3 OH minuses, now you have 1 more, so now you have 4. And that's how you write it. Now, if it's acting as a base, then this will be accepted there, right? So now, aluminum used to have 3 waters, right there. When that OH takes another H, now you have 4 waters, right? And then this, now you have 2 of those. Now you might wonder, what is the charge of these? Let me just calculate it for you. Again, this is not on the AP exam, but it's in your textbook, so I don't want to show you because I don't want you to be too confused. Okay, so the charge, this is +3, this is 0, this is -1. And there are 4 of them, so -4 total. Just do -4. So +3 -4, this whole complex ion has a charge of -1. Okay, again, this is +3, this is 0, this is -1 each. There are 2 of them, -2, so the whole thing has a charge of a +1. Okay, so this is how aluminum hydroxide can act as an acid and a base, therefore is amphoteric.